So we continue our discussion on the Java Lambdas, and in this video we will talk a little bit on the topic of how Java runtime instantiates a Lambda when it sees one. To understand that, we need to understand the anonymous inner class first. So I have changed the implementation again. Now there are we are calling calculate ops two times. The first invocation is using the anonymous inner class that we have seen in the past. So by in case of anonymous inner class, we define or write the class where we are using that basically that instance. So in the method parameter, as part of method argument, we are providing this anonymous inner class with the correct implementation of calculate, which is basically doing the summation. But the second invocation of the calculate ops method is using the lambda expression. So when Java runtime executes the anonymous inner class call, basically what it does, it will create a new object of this class calculator. So calculator is an interface, but because this is an anonymous inner class, this is a class that is implementing the interface. So the Java runtime will create an object of a class with I guess certain it could have a name, maybe a temporary name auto generated, but there will be a class and the object will belong to that class. Now because this is a class, this will be a class, so this class will have its own scope, it will have its own access to this and super keywords, and the most important thing is that there will be an object. So every time we execute the anonymous inner class, the Java runtime will create a new object of the anonymous inner class. Because each invocation would create a new object of the anonymous inner class, so that also means that each object will be different, same as other classes. Each object has its own identity, so that means here in the implementation we can provide the implementation of identity related methods, for example equals or hash code. So that means each instance of the anonymous inner class at the runtime has its own identity, so their own equals and hash code implementation if we provide that one, or it will be guaranteed by the Java runtime. Now if when we come to the Lambda, so in case of Lambda, Java runtime produces an instance of functional interface. So what does that mean? It means that whatever Java runtime will create, it will be an instance of the functional interface, same as the class implementing an interface. But in case of Lambda, it may not always require a new object under the hood. All right, this is the important bit. So it may not always require a new object under the hood. It may, what it can do, maybe it, for example, there are two successive method calls of the calculate ops. So let me write another call here, but this time with a different lambda b. So what could happen when the Java runtime will execute this call for the multiplication implementation? So it will create a new instance of type functional interface to basically hold the lambda. Now when it executes this line, basically this invocation for division, it's possible that Java runtime can reuse the instance that it created to hold this lambda instead of creating a new instance. So it can reuse the instance, all right, for lambda evaluation. So multiple lambda evaluation or executions can share an instance which will be of type functional interface. Now the benefit is that because it may not require a new object every time, so the runtime can apply lots of performance improvements while actually running a Lambda. And it will simplify certain things because Lambdas don't have a scope same as classes. They don't have the access to this and super. They don't have separate this and super. So it simplifies many things. But the downside is because a same instance can be used or can be reused for multiple Lambdas. That means the they don't have that much strict sense of identity that a class would have. So all the identity related functions, for example, equals, hash code, they don't work correctly for the Lambdas. It depends on the Java implementation, the exact JVM that we are using, because it is implementation dependent. But in general, in case of Lambdas, we should not rely on the identity related functions and their behavior, because an instance can be reused for a Lambda. So I know it's not a very straightforward thing to understand, but I hope it makes some sense how the Java runtime instantiates a Lambda, what are the benefits for the runtime, and what is what is the point that we need to remember related to the identity. So there are good things and there are not so good things. That's it on this topic. Thank you.